Thank you for having me. I am a proud University of Illinois alum. It's shocking that I graduated 40 years ago. It seems like it was very much less than that. I did study in communication school. Most of my career has been in marketing and advertising and running marketing firms. As in a lot of industries that are based on service hours, companies grow by buying and selling them, engineering firms, marketing firms. So we were bought and took some time off looking for my next thing. I met a gentleman who had this concept and he showed it to me, and I thought his presentation was really weak. And I said, look, I'm sort of in between things and rusty. I'll redo your marketing for you. So I redid his branding, his PowerPoint, his video, all his things. And he said, well, this is really good. Can you go on a sales call with me? So I said, to where? He said, Santos, Brazil. And I had not been to Santos, Brazil yet. So I asked my wife, can I go? And she said, are they going to pay you? And I said, no. She said, well, okay, you can go anyway. So I went. And when I showed them this presentation and some videos, which I'll show you, they said, this is amazing. Is it real? And who are you? And I said, well, I'm just a marketing consultant. So a few months later, I ended up joining the company, and it's one of those classic startup things. He and I did not get along, so I ended up buying the company from him. That was 7 years ago. And now we've traveled all around the world and showed this to a great many ports. And we have a lot of interest. So let's start out with a video. I make a lot of these because of my background. This is one I made 3 years ago.
The global container shipping industry. Largest network on Earth. Billions invested annually. The mission. More efficient, automated, and data-centric ports. The obstacle. Short-haul drayage. Dirty, manual, and chaotic. A process still managed with clipboards and mobile phones, coupled with inefficient, diesel-polluting trucks. In short, a failure to keep up with increases in ship sizes and efficiencies in automation and intermodal AI. The solution: EagleRail Container Logistics. Automating short-haul container shuttling processes, improving drayage moves per hour, enabling faster ship turns and greater terminal slot productivity. EagleRail, the world's first and only patented electric overhead container conveyance and routing solution. EagleRail interfaces with ship-to-shore cranes. Berth evacuation is quick and automatic. Containers are lifted to automated carriers and routed via sophisticated switching. The operation is controlled by Eagle Eye, our intelligence with vision software. EagleRail also picks up and delivers from backstack areas, receiving and sending import, export, and transshipping containers to and from inland logistics, operations, and rail yards. EagleRail utilizes unused airspace, and each network is modular and customized per terminal, based on flow rates and functional needs, including customs clearance and scanning operations. EagleRail replaces aging diesel drayage trucks, eliminates gating system bottlenecks, vastly improves overall process efficiency of shuttling containers while reducing air and noise pollution. Result: improved safety and quality of life in surrounding neighborhoods. EagleRail can be designed in expandable phases connecting ports with rail networks, intermodal parks, special economic zones, and industrial corridors. Result: a clean, safe, and digitally managed and tracked overhead network. EagleRail also supports loading of today's cleaner, long-haul trucking outside of cities at hinterland intermodal facilities. Drives through city centers can now be greatly reduced. Fully electric, EagleRail reduces carbon emissions by over 60% compared to diesel vehicles. Option: the rail's topside can be equipped with solar panels to augment system power needs. EagleRail goes where trucks and trains cannot. Therefore, it stands as complementary, not competitive, with port automation plus long-haul intermodal trucking and railroad investments. Faster shuttling, smarter routing, cleaner technology, digitally connected. EagleRail, intermodal takes flight.
So what's a marketing guy doing in rail engineering? Well, I guess I became sort of a de facto rail engineer 7 years ago. I have engineers working on our team, rail engineers, electromechanical engineers, process engineers, and I've gotten pretty good at understanding the technology of it. I've been in a lot of these meetings with very smart engineers from a lot of countries, a lot of ports, throwing a lot of challenges at us, and I really feel like the solution holds up. Let's see if this will work here. Obviously, this is the problem. If you've never been to a port town, that is how containers get in and out of the gate. So we are talking about just the gating process. We're not talking about the long haul. We're not talking about shuttling within the terminal. We're talking about getting them from the terminal to a nearby railhead, an intermodal yard, or some nearby satellite facility. This, coincidentally, happened to be the cover of last Sunday's Tribune in Chicago. And yes, I'm an old guy, so I get the print version to get the crossword puzzle. Pollution, health risks raised on freight corridors. If you don't know Chicago, we have a big intermodal facility. That's where the East Coast and the West Coast Class 1 lines exchange containers. And people are becoming very afraid of the pollution and the safety that short-haul drayage trucks create. We do have the patents for both the system and the carriers. A lawyer told me a long time ago to get these, but they're not going to protect you unless you can spend millions of dollars defending yourself in court, but investors like it, so I got them. I'll talk a little bit about technology in detail coming up, but this is our system. It's primarily a carrier that shuttles, has 20-foot locking pins and 40-foot locking pins, because you know containers have two connection points. The larger containers, 45s, 53s, they still use a 40-foot pin area. The two main uses, of course, are going to a nearby intermodal yard. Now, this is a really nearby intermodal yard. Happens to be across the street. If you look at the picture on the left, this is Chittagong, Bangladesh. This is their river port. This is their yard. Their new overflow yard is over here. Currently, to get a container from here to here, they have to take it out this road, go through town, come back around the backside. It's about a 25 to 4-hour journey. So they wanted to go right across the street, and we've developed this little shuttling system for them. And the other trend, of course, on the right is deep sea ports. And as ships get larger, they can't come into seaports. So instead of dredging, they just build the docks out further with jetties, and then you have to sort of get your containers into the terminal. So we also have some jetty systems as well. Of course, one of the biggest benefits is connecting it digitally through IoT to smart cities and the whole network. What's interesting, of course, is ships have digital manifest stowage plans, ports have TOSs or terminal operating software, rail has their loading plan, but when you go on a drayage truck, a lot of times you're on a cell phone and a clipboard, and so that data link drops. So one of our big advantages, of course, is completing the data link. If you can evacuate a port faster, you can make a lot more money for a port. It's like an inventory turn in retail. Each one of these slots has a certain target goal for money. Every time that container sits there another day, either somebody has to pay for it, a demurrage charge, or that slot is losing money. If you can evacuate containers faster, you can have a higher throughput on the same piece of property. The biggest problem in ports today is they're growing about 4% a year, year over year, on the same piece of locked property. Most countries will not give a port larger shoreline, and the town is built up against the back of it. So how does a port go from 4 million containers to 5 million to 6 million to 7 million on the same footprint? You either evacuate them faster, or you create an inland yard somewhere nearby that you can use as a stacking area, and then how do you get them there? So every government we talk to says, yes, I'd love my port to grow 5% a year. I love that extra revenue and GDP. I don't want 5% more trucks on my road because they're dangerous and dirty. There's an old saying in the port industry, which I learned, ports are where old trucks go to die. So when a truck is no longer roadworthy for hundreds of miles, it goes to a port where it does a 10-mile turn, and they're old and they're unsafe and they're just a problem. A friend, my agent in South Africa, showed me a text the other day, 11 children killed in South Africa when 2 container trucks collided. So if you've ever been around a container port area or Joliet, Illinois, and you're stuck behind container trucks, it's a pretty scary. So people want the growth, they don't want the trucks. We also have a huge ESG component, so environmental social governance. Obviously, we're all electric. We consume 60% less energy, 70% less particulates. Social, we're safety. We improve safety around port towns, and governance is what you want to make of it. Clean business, governance. We go to a lot of these countries, and I get these sort of winks and nods about what it will take to get a system built here, and we don't play that game. We'll never play that game. We're American companies. We're held to the highest standards. I will never do anything that's non-reportable to get a project built. This is our calculations of the power usage comparison on a 10-mile journey between a truck and an EagleRail system. We use 60% less energy and 70% less particulates. There's also a triad of benefits for the shippers, faster turns, for the intermodals, a better handshake with the delivery, and for the broad base for the city, less pollution, safer roads. EagleRail created this company called ER-Logics. ER-Logics is a devco. If you understand about the business, there's really complicated rules about who can invest, who can have a legal license in various countries. So we created a legal entity called ER-Logics or ERX. We've been to all these countries. I've probably been to half of those myself. And now with Zoom, the pandemic did something nice for us. It's cut down my international travel. Sometimes it's a 24-hour flight in coach. I can't afford business right now. If you've ever had a long flight in coach, it's miserable. Now we do a lot of our calls just on Zoom. And the outcome of these meetings is what we call preliminary design. If I know three things, I can do some calculations. If I know where the pickup points are, 1, 2, 3 on this map, here's the port, here's intermodal space 1, here's the intermodal space 2, a new one. Then I know the distance of track, and then I need to know the volume between each node. With those three factors, I can create a pretty rough CapEx and OpEx. If they want to buy it by just buying the project outright and have us do maintenance, or they want us to operate it as a service, shuttling as a service, then I could tell them what per box move costs. So the first thing they always want to know is, how does that compare to my truck? If you're going to charge me $80 to go that way, what's a truck going to cost to go that way, right? And I always say that's not the question you should be asking, because there's all sorts of other things we can compare in our price. All those social environmental benefits can be quantified. Number of pollutants avoided, road construction avoided, road maintenance avoided, safety improvement. Those are all quantifiable, and we can actually show why maybe the truck is $70 and we're $80, but it's still a better long-term economic decision. What we have done collectively as we looked at those 72 studies is we've realized what we knew intuitively. We're a really good system under 10 miles, right? Once you go past 10 miles, you should put it back on the ground, because that steel is expensive. You don't want to have it. Most of you have been to Chicago, you know what the L looks like. Our structure is very similar to the L. It's elevated steel, and that stuff's expensive. So the faster you can put it back on the ground, the better off you are. And we did this little analysis, of what types of horizontal movement containers should be handled by. And if it's on the dock, terminal equipment, near dock, overhead shuttling is perfect. If you go a little bit longer, an off the road or over the road truck. If you go long, of course, nothing beats long haul rail. Another way we did an analysis of this is, if a port wants to expand, how many millions of dollars is it per slot? So if I want another slot for a container, what does that cost? We did an analysis. This is based on a Long Beach expansion project. Long Beach is expanding $2.2 billion to get X amount of slot capacity. It comes out to about $1,200 a slot they're going to invest in. If they were to build a satellite storage operation and an EagleRail system, the EagleRail system is about $300 per new slot. And then you have to add in, of course, the cost of the satellite, but it's going to be less than the $1,200. Now, I'll get into a little bit of the technology details. We break our system down, we think 5 components: the electromechanical, the carriers, and then the lifters and loaders, because the load table has to be raised up, trusses and columns, the civil, and then a more civil track, rail, and switch, which is in your bailiwick, and then of course the operating system and our scheduling software called EagleEye. and it's really a toss, basically. It works with the port interface to say these boxes are going to be ready, they're going to this node, and then it starts to schedule where it goes. Where it really matters, if you have a single line system, or just 2 points, it's not that big of a deal. You're just going back and forth. If you have multi-nodes, then you want 3 going this way, 3 going that way, 3 going this way, and then coming back, what are you taking back? The other thing our system handles really well is empties, because nobody wants to touch empties. It's kind of a, it's the hidden secret of the container industry. There's millions of empties containers sitting around the world because they're not profitable to handle. So some companies will take them, and they're really fodder for ships. So when a ship is leaving a port and they have some open capacity, they'll take some empties, right? But they don't like to take empties. They get charged less for them. And then you have to really figure out how to balance the ship out between the heavies and the lights, and but returning empties back to the port on an automated system becomes sort of a less onerous operation. Our system is run from an intelligence center. EagleEye is the master database, but it has to interface on the green line with all these other systems, and then tell the carriers where to go, mainly based on the switching. The carriers are fairly dumb. They just kind of go forward and backwards, and then the switch tells it what node it's going to. And then, of course, all the sensors on the system, and then all the moving components that it has to tell where to move, when to lift it up, when to set it down, when to move the switch. These are basic artist renderings off our beta software design. This happens to be Durban, South Africa. It's a very complicated multi-nodal system. It has two actually berth side pickup stacks. It has a rail yard here. It has another rail yard here, a truck yard, and a truck yard. And this is our vision for what the operator will see when he's running. It's like a remote train system, as I'm sure you're familiar with. Our carriers are married to every container has an ID. Our carriers have an ID. They get married for their time on the journey. We can track all the time where the carriers are, and look at the activities of the load stations, and look at just the general scheduling for the day type of operation. The electromechanical up close, we have 2 types of trusses. One is a box girder, and one is a lattice structure, just like you see here. These are obviously more visually pleasing for installations around urban areas. That box girder is a little bit of a hulking thing. And I'll get into the structure. This is the overhead switch, very much like a ground rail switch, but it's in a framework up above. It has to slide forward and backwards, or side to side, I should say. The carriers, the wheels, it's steel on steel. We have traditional motors from port equipment, a drivetrain, side guide roller wheels, which I'll show you in a moment. The table is just, the table can move in 2 dimensions or 3 dimensions. You put it on the table, it can slide back, forward and backwards, and then up and down. It can also gantry on wheels to follow another gantry crane, whether it's a ship-to-shore crane or an RTG or an RMG. That's the carrier, what it looks like, the skeletal part of it. We have this program where we can add a lightweight aluminum cowling to it and co-brand it. So when you're going to a port and you're pitching them, they don't necessarily want to see EagleRail running around. They want to see their brand running around. So it's a nice branding opportunity. So this is what the current trolley design looks like. There's 4 motors each trolley, and there's 2 of these on each carrier, right? It's designed to be strong enough so that if a fully loaded carrier carrying a box stalls or should have a power loss, the one behind it can actually push it forward. So the motors are strong enough to do that. It has side roller wheels on it, as you can see it here and here, and it also has an I-beam or a crane rail design as well. Our components, we've been redesigning and tweaking this thing for 7 years. Obviously, one of the most important parts of this is the kingpin, locking it to the trolley. If you guys know how containers work from that video, they have those corner casting pins come down and lock. Those almost never fail. So one of the lowest failure rates. And a container can really be hung from 2 of the 4. Even if 2 failed, 2 will hold up the container. The only time, once in a great while, you'll read about a bottom opening up on a container, if you get something like a marble load or some stone order, might puncture through the bottom. So that's why we have the catchment when we pass over passenger areas. This, I just took these pictures a few weeks ago. I was in Savannah. Savannah just put in, there's a thing called near dock rail and on dock rail, and this is near dock rail. On dock rail is very rare, and if you might know this from your curriculum, because you have to build a train wagon 50 or 100 cars, and that's a lot of space on a port that they can't afford. So typically they'll do near dock rail. This is in Savannah. They just opened up what they're calling their mega rail center, and this is a gantry crane that loads the rail cars. But why I'm showing this to you is the rail, the what do you call these things? The yeah, are similar. Our wheel probably won't have a flange on it because there'll be no need. But we use very similar guide roller wheels as well. This is this. I don't know if you guys have ever seen one of these gantry cranes. They're unbelievable, large, right? And they're what's fascinating about them is not only are they gantrying in the two directions, but they're gantrying with a fully loaded box on it, which is really quite heavy. They're 70,000 pounds. But those gantry cranes will have 4 of these and 6 wheels. But the components we're using are exactly the same. So those motors you see hanging on ours, these are the same motors. Those are just above the wheel and ours are below the wheel or next to the wheel. So what's really interesting is when I go talk to ports and I go talk to rail companies and I talk to investors, they say, what's the technology risk? And I say it's almost zero because I'm just using from a kit of parts from other pieces, right? All the crane and all the things from the rail industry and the port industry, I'm just repurposing into an overhead system. So all proven technology. This is, that's one of those gantries back here. And this, I just couldn't help myself. It was like IKEA. They're unwrapping a new one and all the bolts were in a bag and I'm sure there were instructions with pictures, right? And so they're standing one of these things up. I think it's their 8th one, something like that. RMG is rail mounted gantry and RTG is rubber tire gantry. You'll hear those terms a lot in ports. Power distribution, we take the AC, we convert it down to DC. It's on a bus bar, pretty simple. Has to run the length of the wheel. There's an overhead of the switch as well. My favorite truss design, of course, is the tubular truss. If not tubular, then a flat truss design. I think it's just a much more elegant system. We have designed. We were talking about that in our private meetings. What's the strength? Like, how strong should we make this rail? How much steel should we put in there? Now, a fully loaded container, 70,000 pounds, what happens in a power situation where you lose power temporarily and you have fully loaded containers hanging off the steel? How much weight can you suspend and for how long is a big safety question. Interestingly enough, only 2% of all containers are fully weighted out. They call it weighted maxed out on weight or maxed out on cube. They're mostly cubed out, right? The space is taken up way before it's ever hit 70,000 pounds. But we feel like we have to design it for the heaviest containers possible. So that's why, and that will affect your truss length, and it will affect the number of columns you'll put up and how deep you'll put your piers up. Every once in a while, someone will say, why is that not on top of the rail? Why is that suspended? So that's a question I get in almost every presentation. And the reason is most of our interfaces are from the ground up, right? We're taken from a stack. And it's very much akin to factory automation, where you see parts moving around a factory on a suspended rail and being set back down. That's a very, very similar model to what we do. Number 2, suspended weight can go around a corner much faster without having the centrifugal force of it wanting to fly off the top. That way we can make, and it has better incline and decline capabilities. Therefore, the profile could be narrower, the turns can be narrower, there's less steel. So if somebody wants, and that's my patent. I have a patent for underneath. So if somebody wants to come into the market with an above the rail system, we'll be competing. Our track and truss can be single lane, double lane, or triple lane. The one we quote the most is a two lane going back and forth. If it's a lower volume, we can do a single lane. A lot of these really large volumes, you want a third lane because this is your loader lane where you're picking in and the table's going up and down. This is your middle lane, which is taking your empty carriers and putting them in the queue for the next container. And this is your bypass lane, right? So when we go into these heavy volume situations like a rail spur, we create a three-way spur. Now what's really interesting, a single lane can shuttle up to about 400,000 or 500,000 a year volume-wise, and we do a volume rating. And the only way we could do that, though, if you think about it, you have a two-node system and you send your containers headed toward each other, you have to have a center bypass for them to go past each other. So it's not completely single lane, otherwise you'd be waiting for a complete clearance. And you don't want to do that. To keep up your shuttling rates, you have a bypass situation. You design to bypass, but now you have to platoon containers. You got to take 4 and 4 and send them toward each other, bypass each other. So there's a lot more operating. If you do a double lane, it's not quite 2x the expense. It's about 40%, I'm sorry, about 80% more. But once you do a double lane, your capacity goes to about 4 million a year because you can almost never clog that system up, and you go to triple lane. So just for reference, a typical container ship, the bigger ones now, as you mentioned, are about 20,000 containers, which is huge. They started out being 4 and 5, now they're 20. Our two biggest ports in the United States are about 7 or 8 million containers per year annual processing, right? The biggest ports in the world is 40 million. Singapore or Shanghai, it's unbelievable. Singapore, Hong Kong, they do about 30 million. So we have been approached to do systems that are 200,000 shuttling per year to 5 million shuttling per year. So it depends on, that's my 3 components, volume, pickup nodes, and length of track, and I could do a pretty good estimate on that. Of course, we have a catchment. We were talking about it. Something for students like you to think about, this catchment. Since the corner castings only fail like 1 every 2 billion uses, and the bottoms open up maybe twice every 10 years, it's a very, very rare occurrence. We'll definitely, from a safety perspective, nobody in the world will let us put a system without a catchment crossing. But what should it be? Right? We talk about this all the time. Should it be some super strength fabric? Should it be a metal? Should it be a chain link? Should it be mesh? What should it be? And how close should it be to the actual bottom of the container so that you're not building momentum on the fail? Right? So we have several systems we've designed, but I'd be curious to think what you think a good catchment would be. We have the standard corner cast locking pins, but we've beefed them up a little bit so that we make sure this is the failure rate of the corner castings. And again, a container can hang off of 2 of them, if even 2 failed, which this is our overhead switch. This is a couple different designs. One of the things people come to us and say, well, right now, where the boat parks is called a berth. And so they say, well, I have a berth here, but then in 5 years I'm gonna have a berth here, and then in 5 years I'm gonna have another berth. And so we have this system where we can create a loop turnaround once it gets to the end of the first one, but then we pre-design it so that when they expand, you have a pass-through system and you have a pass-through system. We really wanna know when we're designing a system, what's your 30-year volume? We don't wanna know what your current volume is because 1, we wanna support the capacity. 2, the only way people operate ports and buy those expensive cranes, those cranes are $10 million each, is to get a 30-year operating concession. So that's how you can lease equipment, right? I'll move your boxes if you give me a 30-year agreement to do it. We have to have a similar type of long-term agreement in order to afford this equipment. So I need to know when that berth goes online, and have the complete volume projections. This is what I was talking about for the 3 lanes for if you have a heavy volume pickup situation where you have your pickup lane, your empty carrier bypass, or your empty carrier queuing lane, and your bypass lane. That's just the load table we talked about, and that's the gantry version of it. That's a fixed truck version. This in Santos, Brazil, we have a special challenge because they have, this is Sao Paulo. I'm sorry, this is Santos. Sao Paulo's up here, and it's one of the biggest escarpments. You know, a lot of ports are put on the shorelines lower than the city. So how do you get containers up? Right now they have 2 roads, and they don't want to build a 3rd highway, but they want this port to keep growing 5% a year. And it serves mostly the Sao Paulo consumption market, but it's also the launch point into central Brazil for all this cargo going in. So we have designed a system. One of the other advantages I didn't mention for suspended overhead is we don't have to worry about the undulation of the ground, right? We can just level those things out, or close to level them out. We're working with 2 ski lift companies, Doppelmayr and Poma Leitner out of Europe, to say, how could you do a rope assist? So once our system can go 6% steel on steel wheels, which is quite a bit steeper than a ground rail. But once you get over 6%, we can't pull that weight. So we have designed conceptually these ski rope lifts where it'll have a hook which will grab the container for certain portions of the run when it goes above 6%. How we get started with, I mentioned earlier, we have 2 phases. We have an information gathering and concept phase. This is what Durban looked like when it was in that phase with these different nodes. And we have what we call our from node to node distribution. And this is where we can do a pretty quick down and dirty representation of cost. Typically we get a green light and they go, okay, that's within our budget, or that's feasible over 30 years. Now what do we do? Well, what we want to do now is we want to simulate it. And there's a lot of simulation programs out in rail. We use one called FlexSim or FlexTerm. It's one of the largest ones in factory automation. So Tesla uses it, FedEx uses it. Anytime you have what's called conveyance and you have things running in a loop, you want to before you build your factory, you want to simulate it. So it's an algorithmic system. Just knowing that we're going to move X millions of containers or X 100,000 per year isn't the best design criteria. It's your peak. What's the most you'll ever use at one time? So we have to design backwards from peak throughput. So once you put it into the algorithm, we've actually, this is real. We actually shrunk all the little EagleRail pieces and imported it into FlexSim. I can change the rate of acceleration, deceleration, lift, and switch movement. And once I do that, then I put the nodes in. I put the volumes in each node from the from table, and then I press play. And if you've ever seen simulations, they can work in real time. They can work 100 times faster. You can just see your entire system starts operating. You'll immediately see problems. You'll see too many containers over here, not enough carriers over here. You're like, holy smokes, I got to redesign this thing. So we would never even start true engineering drawings until we actually did a simulation. Again, this is the Durban, South Africa situation. Routes, we just talked about, routes and nodes, volume count. Then this is a visual simulation. So the video I showed you earlier, that's with an animation artist I work with in Chicago, but this is actual output from FlexSim. So FlexSim can also output visuals. If you want, it'll give you all your data points, trip time, container wait time, whatever parameter you want to measure, you can get a measurement of it, and then you can see it. You can see it actually operating. I think this has some motion in it. Those black diamonds are not structural pieces, they're decision points that the software has to make a decision on acceleration, deceleration, and movement, etc. So this is that loop I showed you earlier where we can actually bypass it. This is the fixed truck loading, the tandem truck loading station. We like to use tandem loaders on the trucks for 2 reasons. One truck can drop off and it could pull forward and then pick up. So it actually is doing a dual process. And or if one of those should have a fail point, then at least we have one load station that's still operating. And when I first started this company, I couldn't afford a $10 million prototype, but I met this guy from MIT who runs their maker lab. And he said, for $100,000, I'll come to Chicago and I'll make you a 1/10 scale model, so which is what he did. He ordered a couple of Chinese plasma cutters. We fed sheet metal in for a couple months. He cut all these parts out. We folded them, tabbed them, sprayed them. He built a control booth, and it actually ran for a little while. It's pretty cool. That's me. good friend of mine who does my website and stuff, I saw his gallery thing, and he started making this series of animals and bugs mesh with machinery. And I said, Michael, why don't you make me one with an eagle and a container? So I commissioned it. So that's our fine art. So I guess we go to Q&A, right?
We have time for some questions.
Yes, sir.
I've got one.
You, sir.
You said, I think in one of your early slides, you referenced something like 70% reduction in emissions. Why isn't it 100% if it's electric?
Because we count the source of production of energy as well.
So locally, it's
Locally, it's zero. And we actually did the electric generation. We took national surveys. These are U.S. Department of Energy numbers, coal firing, natural resources, et cetera. So we blended those together. But it is, yeah. Yes, sir.
What does maintenance look like on these systems? What's the time frame that you're looking at before replacing the rails or having any sort of large maintenance outages?
So the question is, what does maintenance look like from schedule for the moving parts and the fixed parts? We have a program. Our program in mind is obviously, like everybody, preventative maintenance, monitoring and preventative maintenance. We think there'll be a lot in the gearing and the bearings because there's a lot of weight on those things and a lot of heat being generated. The carriers are probably built, we think, with about a 5 to 7 year life cycle on the mechanical parts, not the frame, not the weldment, but the actual moving parts. We think about a 5 to 7 year cycle on those. We hope the track and truss is about a 30 year. We hope that stuff won't need that much maintenance. But every time we design a system, I didn't show you this, but I do a video. We do an M&O shed that we actually have 2 or 3 extra carriers in there and 1 extra switch that can be moved in at any given time. And then we do preventative maintenance. And then one of the questions I get a lot of times is, what happens if you have a complete system shutdown? How do you deal with that? So the good news is most ports are on a backup grid situation. And so they're, I don't know if it's called class 1 or grade 1 power, but when like in Durban, South Africa, they have power outages planned every 4 hours. The port never has a power outage. And most ports have good power backup. EagleRail will have its own power backup system for redundancy as well. If a carrier should go down, again, we'll have pull-offs for things to be pushed. One of the most interesting things we can do, and this is a little off topic of your question, during that simulation, I get a lot of tough questions like, all right, so what if my system's down for an hour? What does that do? And a lot of people don't get this analogy. In a lot of the countries I go to, I say, O'Hare in a snowstorm? They say, I don't know what you're talking about. I go, okay. When O'Hare goes down, the whole country goes down for a couple hours, and it really screws with our air traffic for a day and a half. So what we like to do in our simulations is actually shut the system down for an hour and then say, is it 8 hours, 10 hours? When does it come back up to full capacity? So that with an overhead shuttling system, even with a shutdown, planned or unplanned, you'll still far out pace truck reliability. But we don't have one up yet, so I don't know the definitive numbers on those. We are working, our prototyping is being done out of Minnesota. They're a kind of a prototype-only shop. They build prototypes for all Deere, Caterpillar, BNSF. They build mostly heavy equipment and rail equipment. They're building our first carrier and lifter, so they're going to help us define what those maintenance specs are. And then mass production, we were going to do it in China, but then that whole thing blew up. So we're going to do it out of South Carolina, and we'll have a test track, a bench testing track. Hopefully next year, we'll be running those things, 24/7 and just seeing what our maintenance intervals are.
Follow-up for your structural design, are you accounting for potential earthquakes?
Potential earthquakes, and more so wind shears. We're much more, most of the places we go, there are some earthquake zones that we will design with. I see you got earthquake braces behind you there. So we do have an earthquake rating, but we have a wind shear rating, more importantly, because we're in a lot of coastal areas which get a lot of tropical storms. And so we have a rating at which we will minimize operations, a rating at which we will halt operations, and a rating at which we will remove everything from the track and park it at one end. So I think that is a number I can't pull off the top of my head. I think it's about 130 miles an hour, I think, for a complete system shutdown.
Great presentation, Mike. Appreciate you.
Thank you.
One question regarding the external storage facilities, so the other end of the line away
Right.
from the port. How do you envision those operating? You would be placing the containers on the table, and then there'd be a secondary move. You'd be grabbing it from a gantry
Well-
system, stacking, or going straight to chassis? Or?
No, we can interface with all types of loaders. So we can put it on the ground in a I hate getting old. What do you call those things that drive over the container? The straddle carrier. Straddle carrier can pick it off the ground. We can go on a table, and then a reach stacker can get it. We can go on a table, and then that could be put, an overhead gantry can get it and put it on a truck or in a stack. Or we even have an in-stack designer where there's no truck at all, where you have a cantilevered RMG. It could just go right underneath the cantilever and be put right in the stack. It's called our in-stack load situation, and that's really popular because most rail yards or intermodal facilities now are going to RMGs, big honking RMGs, and we're a perfect interface for that. As a matter of fact, we're talking to, I can't say confidentially because we're online here, we're talking to several large ports in the Eastern Hemisphere and the Middle East about exactly that. What is the load, what's the handoff configuration on the intermodal side or the rail side?
That's a great answer. So how high would you come in? What would the stacking for high, or whatever they want?
Well, let me see. The video I have has something confidential, and I don't want to broadcast it. If we're coming in next to it, we're just at our normal height, right? If we're coming in, you have to clear a lane for us. We can't come in over a stack. So if there's a stack lane, EagleRail voids that stack, okay? But our height is pretty standard. So you have the truck chassis, the height of the container, the height of the carrier, and that's sort of the clearance we have. And I think that's 10 meters to 11 meters, something like that, is our standard height. So a fully loaded container truck can drive underneath it is our base minimum. Anybody else? Yes, sir.
How close are you to having a system in operation, actually constructed and up and running?
Well, I'm negotiating two right now, one in the southern United States, and then one in, I can't say what country right now, but I have two under consideration. It's been this really interesting thing. If you want to think about not the marketing side of it, not the technical side of it, but the entrepreneurial side of this. I show this video. I've been showing stuff like this for 7 years, and they say a couple things. This is great. Why hasn't this been done before, right? It's so obvious. Once you see it, you go, well, this is so obvious. Why isn't it? And it's not the technology. It's getting multiple parties to agree to do it because I'm leaving one property, entering another property, and I'm crossing multiple jurisdictions. That takes a lot of paperwork, legality, insurance, right, safety. So, yes, sir.
So that raises some questions for me, which, I mean, what volume of traffic do you need to have to make this, a cost-effective investment?
Well, that takes only two of my three factors. It's distance and volume, right? So on a short system, it could be 200,000, 300,000. In a longer system, you want to be 800,000, right? Once you get up into some of these larger ports, it's a really good financial decision for everybody. Let's say the port, the investors, EagleRail, it becomes really, right, once you get, but we've got some systems as low as 200,000 that can make money, right? But we want to work with the bigger developed ports, 400, 500, 800, sort of, and that's our minimum. That's per annual moves.
And what is the capacity of, let's say, a single track line with your passing sidings?
Well, that's what I mentioned earlier. It's about 400,000 on a single track. And once you get above that, you should go to double lane. And that's 4 million. That's just, just 10x is crazy how much more capacity you have. So then you have that decision. We talk with a lot of ports, well, a single track will work now, but in 10 years, I'm going to double track. So then we started to design the column and the spar so that it could have one track and still be stable side to side from eccentric loads, but then in 10 years we can add that second track and come in. And those extensions, I showed you those extension loops if you add more pickup drop-off points. So it's about 400 on the single, about 4 million on the double. But the other thing is, when you have multiple nodes, think about this as a logistics system. Node A doesn't have to always go to node G. Node A can just be A to B, A to B, A to B, and B, or A to C, A to C. So you don't necessarily, each node system could be designed separately for the volume on that node.
Other questions from the room?
This is just a bit of a question about your track design. I was just looking at I remember on some of your slides you were talking about how you were going to design like the sidings. Like, why did you have like 2 individual tracks instead of just like the typical like rail siding where, like, I don't know how to describe it, but like, it's like it sort of splits from one track. Like you sort of have 2, like sort of a track that sort of moves around.
Like a permanent switch?
Yeah, something like that. Is it like maintenance, like too much maintenance because so many like, containers go around every day?
I'm not sure I understand the question. We always have to switch. Is a switching question? We always have to switch from one line because it is a single rail, right?
Yeah.
And so I don't have the advantage of having the double. I have to move the whole thing over at one time and move it back. So we always have to have, and on sidings, we always have to have a switch.
Yeah, it just doesn't look like a conventional like rail switch, like when you just look like there's like a
Yeah, we don't have that little flippy thing that.
Yeah.
No, you can't redirect it. You have to move the entire rail over. Now the good news is that rail moves. It's about 10 seconds from side to side. One of the things we found out when we did our simulations were 2 problems. One, not having enough empty carriers at the right node when that node gets busy. And 2, was moving the switch as few times as possible because that switch really hinders your throughput, right? So your scheduling software wants to send 10 this way before it moves and 10 that way. You don't want to move every container back and forth. So that was a thing we discovered in our simulation. Yes, sir?
You showed your scale prototype that you built. How much of that was just visual, and how much of that was actually partially a prototype of the design itself, of the parts and the machinery itself?
You're too smart. It was mostly a diorama. It was mostly a visual.
Okay.
We were trying to show scale. The biggest problem was weight. We couldn't simulate the weight. We can simulate the height and size. We couldn't simulate the weight. And so it was more of a backdrop, more of a marketing backdrop, absolutely. But it was kind of cool. It was in a room about twice as big as this, and we had our desks underneath it. It was kind of kitschy, and customers loved seeing it. I actually have a video of it running. It ran really well, I told you guys, for about 18 months. And then I got out of tune. The parts didn't line up anymore, and the wheels started to chatter and squeal. And then I had a big presentation once, and I said, no, I'm never doing that again, because I was like, that's a non-sale item. So I just made it a visual. But yeah, we couldn't really use it for that. Yes, sir?
A little bit more on the switching question. It kind of reminds me of a roller coaster switches. So I'm curious, have you considered suspending the carrier while the switch moves and having like a straight section that you switch between the 2 tracks?
I'd almost have to diagram that to understand what your question was. Although a lot of people, my friend calls this the container coaster project. So I was a little bit inspired by the roller coaster industry, especially that lattice design. But I don't say that again, so I understand about the switching.
Yeah, I'm curious if you experimented with having a carrier. Say you have instead of your switch where you have essentially putting in a different section of track. You just have two straight sections and you shift one over. So if you have a double track section, you just shift it over.
Yes, that is actually one of our designs.
Okay.
Maybe I went past it, but on
Got
some
it.
of them, we absolutely do that. You have just two straights moving. You don't have the curve in there.
And you have the carrier on.
Yeah.
On the, gotcha.
Yes,
Cool.
but
Even slower to move, I assume.
because you have 70,000 pounds on it. And you know where we use that? Sometimes when we want to do a turnaround, but we don't want a bulb,
Yep.
we just slide over to the next track. You know, it'll download one container, and then it'll move over to this side, and then a new container goes on and starts going that direction. In that case, it does move with the carrier on it, but the carrier at that time is empty.
Got it.
But moving a 70,000 pound box with a carrier, but yeah, we have that in part of our toolbox. Great question. Yes, sir.
I'll go first since I'm here. I'm curious about the supports and how it's hanging, and you're talking about connecting over someone else's property. So do you need to get land acquisition rights, or is it more like utility where it's going over a farmer's field? And
Most
how-
of our routes are following some other infrastructure route, right? A road, a rail. I mean, you guys know more than me. The right-of-way on a rail is really wide, right? So a lot of rail companies that we are feeding are interested in letting us use some of that siding, road siding, power corridors. But there will be some times where we're cutting across, you know, not occupied property, but adjacent to occupied property. And you definitely have to get you use usage rights. You can never buy the property, but you have to get a concession, a usage right concession. So there was a situation in California just like that, where they had a small, their terminal was fairly small. It was only 25 acres, which is tiny. It could fit 2 ships on it, but they had 500 acres 5 miles away. So they said, okay, can we consider that? The good news is when I first left the port, I was in pure, what do you call it? I was in industrial property. It was great. There was a small section where I went next to a housing development, and one of the things we passed over quickly is the sound. Without the flanges on the wheel, which is really what causes the squeal of a rail, the metal on metal is actually pretty quiet, right? So we were about 70 decibels, which I think is equivalent to a vacuum cleaner. So we think we would get rights, even in strict California, to operate 70 decibels. It was maybe 200 feet from a housing development, and I think we were going to get clearance on that. But we would be fenced off, so there'd be no underpassing. But at that point, they were questioning visual pollution and noise pollution from those. But we try to follow industrial corridors wherever we can.
Yeah, my question's kind of related to right-of-way too. If you have plans to share the right-of-way like with railroads, if you can build on top of the rails, the tracks, because for example, from Santos to São Paulo, you have a rail connection between both of them, and then you can just hang the containers up.
Have you
the
been
rail
there?
And then get there.
Have you been there?
Yeah, I'm from Brazil.
That was one of our solutions on the face of the ocean, on the right bank, right? Going down to the very end, there was a single ground rail line, and the only way EagleRail could get those containers was to go over the ground rail. So we had designed a super tall support structure where we're literally flying over. And at that point, that's a single stack, right? And that area, some of the newer areas in Brazil are double stacks. Everybody's trying to make a double stack clearance when they can, right? But you have a lot of places you have tunnels that prevent that, or power lines that prevent that. But absolutely, we did propose that to the, yeah, it's not Cadespi anymore. I forget what it's called, but yeah, we proposed that to them. So, but great thinking, yes, over top. Other questions? Great questions. One more? No, I thought he was handing you the mic. I thought it was a question.
There is one question from online.
Is this some sort of anonymous hostile question?
It's kind of a general question. What are the assumptions or given attributes for the system to work as planned?
Well, I have to have access to power, for sure, right? We use a certain amount of power. I have to have right-of-ways. I have to have the amount of volume to meet the price of the steel structure, right? That's one. I have to have counterparties. I have to have a person on one end saying, I will receive this, and one end saying, I will ship this. I have to have jurisdictions saying, you can travel over my property. I have to have a bank that will say, I will finance this over a 30-year contract. And I have to have, got a real important one. Don't get old, I'm warning you guys. What was the last one that I need to have? God, it left my mind. But you need to have all these agreements in place, the volume, the pricing, the funding, and you need to have sort of, in certain jurisdictions, union buy-in. Now, the thing that's interesting is we're not a port piece of equipment, so the same union port operators that are putting it on a truck will put on our equipment so that their jobs are untouched. They're just handling with something different. The long-haul drivers are typically unionized. The short-haul drivers are typically independent. In a lot of countries, they call them pirate truckers or scab truckers, whatever, right? So we're replacing those. But in some, the general question is, in some, I have to have union involvement or union buy-in for that as well. And definitely the port operator has to say, yes, I want to do this. If it's multiple port operators, then the port authority says, yes, I want to provide this in my port as an amenity. Because one of the things people don't realize is ports compete with each other up and down the coast. Everybody's trying to steal Savannah's business. Everybody's trying to steal, and they're trying to steal from South Carolina, they're trying to steal from Florida, right? And how do you do that? You say, I'll turn your ship faster. That's what you tell them. And I'll get your container out of here faster. And how much faster? I'll turn your ship. You want to turn your ship in 3 days? I'll turn it in 2.5, right? Or you want to get your box out in a week? I'll get it out in 5, right? You got to give them metrics. And they try stealing business. So a lot of port operators are saying, if I could put in a shuttling system, I could turn my ships faster. I can get these boxes out faster. So that would be what we've coined the ultimate tenant amenity for a port operator, to provide a shuttling system. And that's one thing that's pretty interesting. Even as a brand and a marketing guy, most of the time I don't talk about the EagleRail system because that's too specific. I talk about the generic concept of overhead container shuttling, because then people go, all right, he's not trying to sell me something. He's talking about a kind of a conceptual level. Because, truth is, we did have some IP theft from a Chinese company that tried to help us. And when I found out about it, this is a true story, I went to bed really sad. I was like, God darn it. They said it was going to happen, and it happened. The next day, I threw off my covers. I was so happy. I was like, okay, this tells me there's a market. Now I'm investing in a market. If somebody wants to rip me off, that means there's a market here. And 2, all I have to be is better than them. I'll take a Coke and a Pepsi any day, right? Now I got a competitor, I got a target, I got somebody to challenge me against it. I'm not trying to create a whole industry by myself. I'm just trying to be the best in an industry. So I think in 4 or 5 years, EagleRail will be around. I think there'll be a Chinese version around. I think there'll be a Dutch version around. I think there'll be 3 or 4 of these. I hope. I hope. And I think, we were out of the box first. We have the patents. We kind of invented the concept. And I hope we'll go down as a proud alumni of Illinois, having gotten this off the ground. How's that for an ending, Mark? Did I nail it?
I think you did. So, again, well, thank you very much.